Alright guys, so if you are starting off this week's information about electron configuration with this big picture, then I will be alluding to the details that you will learn that will kind of help you later on. And if you are watching this big picture at the end as a nice recap or review, then you will already know some of these details, or all of these details. So the big picture that we're talking about is the quantum mechanical model. Okay, it is our current model of the atom that we accept. It's replaced the Bohr model, and we've already learned a few things in class, and hopefully you read over the weekend chapter 5 section 3. But we learned in class that the quantum mechanical model is a way to describe the probability of where you will find an electron. Okay, and we also talked about these electrons kind of needing an address. So we can describe them based on their energy level. So remember, N equals the energy level. Okay, the further you are, the higher your energy level, the more energy those electrons have, or that atom has. We talked about sublevels. So within those energy levels, electrons tend to fill certain sublevels, first, second, third, and they become more complex as they get higher up. So sublevels were those S, P, D, and F sublevels. And it's just areas within the energy level that also are varying in energy. And then the last thing we learned about were atomic orbitals. Okay, those are those very small regions within the sublevel where you will have like a 90% chance of finding an electron. Okay, so whether you are starting with the big picture or ending with the big picture, we have learned these vocabulary terms. Okay, that N equals your energy levels, and on the periodic table you have 7 energy levels. Okay, so your highest possible energy level on the periodic table is 7. But that describes electrons and atoms in their ground state. So if you were to excite electrons, they can jump past the 7th energy level. We don't discuss that, and we don't even really talk about the 7th energy level in pre-AP Chem, or any chem, any of your first chems. Okay, so you've got your energy levels. Within your energy levels, you have your sublevels. And within your sublevels, you have your atomic orbitals. Okay, so the big picture of the quantum mechanical model, got your nucleus. You do have energy levels, just like Bohr thought. Let me go get a black marker. And I'm hoping that I can draw these energy levels nicely, because I'm not the best at circles. So you've got 1 energy level, 2 energy level, 3 energy level, 4, 5, 6, 7, so on and so forth. Okay, but they are not fixed paths orbiting around a nucleus like Bohr thought. Okay, they're just regions. I'm going to highlight these in yellow. So those stick out to you. Oops, I told you guys I'm not good at circles. So these stick out to you as the energy levels, because I highlighted it yellow here. So this would be N equals 1, N equals 2, N equals 3, 4, 5, 6, 7, however many you have. Okay, so atoms fill the lower energy levels first. Okay, you can't have an atom out here on the 3rd energy level if these are empty. Okay, so they're going to want to be in energy level 1 first, and they're going to fill sublevels in the order of S, P, D, and F. Okay, so sublevel S, you do have an S sublevel on energy level 1. And the S sublevels, remember, are in the shape of a sphere. Okay, energy level 2 has an S sublevel. I'm doing it in pink because I highlighted sublevel pink up on my vocab. Energy level 2 also has P sublevels, and those were the things that were the dumbbell shape or the infinity sign, and you have 3 P orbitals. Okay, now they're 3-dimensional. It doesn't look just like this flower. I printed off a picture for you. So this is your S sublevel, and it's a sphere, a 3-dimensional sphere. And then your P sublevels are these like dumbbell shapes. Some of them are coming out this way, some of them go diagonal, some of them are vertical, but you have 3. Okay, so mush those together and you get sort of this shape. Okay, energy level 3 has not only the S, but it has the D. I'm not going to draw it because I'm going to still need to write. And it also has D, okay, which are just kind of more dumbbells in more dimensions. Okay, so I am not going to show my electrons filling in these sublevels as a picture, but just know that they would fill in S first, and then energy level 1 doesn't have P. So after they fill S, they move to energy level 2 and fill the S, and then they fill the P. Okay, one at a time. Then it would move up. So I draw my orbitals and my sublevels like boxes. Okay, so that is where, if you've already done the details, that's where you get your orbital diagram boxes from. So energy level 1 has only your S block. Your S sublevel. And if you've done the details, you know that. So they have 1 box. You already know that you can have 2 electrons per orbital. Okay, so you could have 2 electrons in this box. Okay, you will learn later in the details, if you haven't already, that they spin in opposite directions. So you indicate that with 2 arrows. Okay, so energy level 1, sublevel S, 2 arrows. Okay, energy level 2 has an S sublevel and P sublevel. Okay, so 2S and 2P. 2 electrons in your 2S, and 6 electrons can fit in your 2P, right? Because you can have 1, 2, 3, 4, 5, 6. And again, those spin in opposite directions, and they filled 1 box at a time. Then you move to 3D. Okay, so they would fill 1s2 first, and then 2s2, and then they would bump up to 2p, 6. Energy level 3 has s orbitals, p orbitals, and oops, I'm going to have to write over my, dang it, vocab. I don't want to do that. Okay, so again, they're going to fill the lowest energy first, so they're going to fill 3s2 first, 3p next, 1, 2, 3, 4, 5, 6, and then you notice that the 3D kind of pokes out into the next energy level, into n equals 4, if we were drawing that. So technically, 4s would get filled before your 3D. Okay, and I'm not doing that right. They should go one at a time. So this is the big picture. This is the quantum mechanical model with the weird shapes and the sublevels and the orbitals and the electrons filling one at a time with opposite spins. You've learned all of this stuff already if you've done the details. If you haven't, then just know that this is what we're going to be learning, all of those things. So this is where you can stop this video and move to the details videos. Do those in order and take notes where I tell you to stop and take notes.